Can I just double check? Is there anyone who has OBS that would be able to record the session for upload afterwards? I just prefer not to share screen and record at the same time because it doesn't always capture optimally.
Yeah, I am recording, but I'm also kind of working on some stuff in parallel, but if no one else is recording, I can put my other stuff away. That's okay.
I can have a recording running on the side just in case we need a backup. But if you want to do a duplicate and then we can just take whichever's better, that would work for me.
Yeah, sounds good, Jeff.
Awesome. Okay, cool. So I think we can kick off now and just let people trickle in as they arrive. I guess I'll hop on video here to say hello. So yeah, this is the seventh cadCAD community call. We run these monthly, and the point of these calls is to get intros to all the other people working on cadCAD. As we most of us know, this is a new tool, new technology that there's a lot of work being done to shore up both the functionalities of the tool and expand all the models that currently exist. So this is a space that we can come together and get to know other people who are working on models, what people are interested in modeling, where there may be synergies or overlaps with what's already been produced, and trying to get more knowledge sharing and awesome use cases out there in the cadCAD community. So we normally open up with a quick round of introductions. I know we've done this a number of times now, so some people may have introduced themselves a few times, but I would definitely love to open up the floor to anyone who is new here or anyone who has something in particular to share. If you've worked on any models, or what would you like to see modeled if you haven't worked on any models yet, or what you need help with in the cadCAD space. So I'll start to model. I'm Jeff, working at the Common Stack and Block.Science, and spending a lot of time in the cadCAD community because there's definitely a lot of overlaps with the different complex systems that are being built in a bunch of these different communities. So yeah, happy to be here and help hold this space to facilitate the knowledge transfer of everyone working on these wonderful models. Is there anyone who would like to jump in and give a quick introduction? Any models you're interested in or have worked on, or questions for the community?
Hello, this is Gus here. This is my first cadCAD community call. I know a couple of you guys. Yeah, currently I'm working with a project called DAO Education. We're just approaching, let's call them no-coners to the Latin American market, and we want to bring them into the crypto space and teach them as long as we can, of course. We're just starting this project, and I love what you guys are doing at cadCAD, and I would love that at some point we introduce cadCAD models into our program. So we just want to approach more with this community. I'm starting to do my cadCAD education model myself. So just at the very beginning, and that's it.
Thanks for sharing. Anybody else?
Hi, I'm Daniel Friedman. I'm a friend of Zargum's, which is how I learned about this project, and I'm taking your online course, a beginner in Python, but really appreciating this integrated effort. And right now I'm under the Markov blanket of the Active Inference Lab, which is a project related to free energy principle and maybe a few other topics that people like. And so one thing that kind of excited me was just combining complex systems approaches and specifically like cadCAD as an instrument to talk about active inference and communicate it and make it participatory as well. So looking forward to this conversation. Thank you.
Awesome. Thanks for coming, and definitely happy to help integrate with different communities. If you have more people who are interested in data science, complex systems modeling, and all that, we are happy to work with as many of the people with background skills to bring into the community as well. Thanks for joining. Anybody else?
Hey, I'm Nico. I've been around here sometimes, but not really. So guess I'm kind of new. Yeah, I work with Shawn, and I'm trying to find out what's under the hood here at cadCAD, you know? So I think this is like super powerful software, and you guys are making it like such a revolutionary work, and it's all open source, and it's so wonderful like that. So yeah, I'm gonna be chilling around here, and you know, hopefully gaining at least a fraction of expertise that you guys have. So yeah, thanks for having me.
Nice. Thanks for joining. I've also seen you in a couple of the Luna Swarm chats, and also there seem to be a number of kind of open community modeling initiatives at the moment, whether the One Hive Luna Swarm, the Gitcoin grants modeling sessions. There's definitely some really exciting areas to get involved. So thanks for joining there and joining here as well.
Yeah, totally. I'm super happy to do so. I'm excited. Thank you.
Anybody else before we head into the presentation round of the call?
I'm Chris Katoya. I am a program manager at Block.Science. Really excited about the community that's growing and all the efforts that Jeff has been putting in to make that happen. So yeah, I'm super eager to see Shawn's presentation today.
Awesome. We were just giving a quick opportunity for intros and any models that you've worked on, models that you're interested in seeing, or if you have any other questions or need help in cadCAD, feel free to jump in and introduce yourself. Otherwise, we will move on into the presentation section of the call. Give one last chance. Awesome. Okay, so yeah, we'll kick off into the next segment of the call where we'll have Shawn Anderson presenting the cadCAD modeling that he's done on the Token Engineering Commons Hatch. So this is basically the initialization of a DAO using the Common Stack design pattern, so the augmented bonding curve and the conviction voting DAO, although the hatch is, well, maybe I won't take all the thunder away from you, Shawn. I'll let you jump into it and show everybody all the cool stuff you've been working on in the cadCAD model.
Thank you so much, Jeff. Yeah, I was just going to jump in when you started saying bonding curve and conviction voting, because that is the key piece that the TEC community is sort of innovating on. We had a shift. So we were planning this big launch. The TEC community was going to launch bonding curve and conviction voting and do the hatch. And there was, it actually came from the legal working group. There was a requirement to sort of slow things down and have a phase 1 and a phase 2 of the hatch so that there can be this initial sort of buy-in, like hatchers can all co-vest and make an initial DAO. And then that DAO is actually the legal entity that's going to launch the bonding curve and the conviction voting. And so this just completely simplified things on the legal end, and that was the initial push for this. But kind of a happy accident was it ended up really simplifying things on the technology end as well. So it was kind of cool to see something starting out in legal and then just simplifying everything in the technological side of things. So the TEC, the Token Engineering Commons, they're doing a two-phase launch. So one is, firstly, is just the hatch, and what the hatch is that it's really based around this concept of impact hours. So the TEC has a really nice workflow going. It's composed of several working groups. There's like a communications working group, an onboarding working group, a soft governance working group, and these teams all work asynchronously, and then come together every Thursday. There's a community call, and the whole sort of community comes together and shares what's been happening. And all of this is happening. Like the TEC is this highly functional, highly operational DAO without any sort of blockchain, cryptocurrency, token, nothing. It's really just a collection of sort of norms and people coming together on social contracts. And if there is one, oh, let me share my screen. Share your screen. So of course this is based around technology, but the goal of the TEC is to not be a technocracy. So the idea is that most DAOs, most crypto projects start with a couple of programmers or a handful of programmers, and they decide all the rules, they launch the system, and then they go promote it, market it, and get people to join. But what we want to do with the TEC is not be developer centric. We want to be human centric and cultural centric. So I think it's been about 4 or 5 months that the TEC has been actively working and building, all without any sort of like trustless, blockchain technology binding people together. It's really centered around cultural ideas. And so the technology that's being fully utilized here is primarily Discord, Telegram, and then there's a forum. So this is the first sort of tech deploy that allows the TEC to continue progressing. And this is where we start with the hatch. And things have been really evolving through the forum, just through forum posts, and there is a simple voting mechanism that's been implemented here, just with like stars and upvotes. And there is a source cred implementation that's active in the Discord server. But the first sort of tech build is the impact hours. And the system that's in place here from the common stack is the praise system. So whenever someone contributes in a certain way, anyone else can call out that person on Telegram and cast praise. So it's just a simple Telegram bot. Anyone can dish praise to anyone else. And by using that Telegram bot, the praise gets logged into a simple spreadsheet. At the end of every month, that spreadsheet gets rolled up, and praise gets converted into impact hours. And again, impact hours are simply just maintained in a spreadsheet. So everything is like bare bones, off chain to begin with to create this sort of cultural build. But as we move into phase one of the hatch, we are now finally moving from this just being bound by sort of social contracts into more of a formalized, what you could call trustless system that is moving on chain. And so how we're modeling this, the phase one of the hatch, is following this cadCAD ethos of, to simplify things, it's like requirements gathering, and then mathematical specifications, and then modeling and simulation. And so I'm going to walk you through how we did that, and then I'll get to the modeling and the simulations. But it all starts in the forum. So we made this TEC Spec working group, and this is to define the specifications, all the technology specifications of the TEC. And it starts here, the hatch. So these are essentially the three components that are in the works. The hatch is coming up soon. It's ready to go. There's the Dandelion DAO, which is coming out of the hatch, and this is like the DAO God mode, essentially. This is a voting mechanism that allows token holders to vote to change anything about the DAO, to augment any parameters and anything. So this is like the DAO God mode, and the main purpose of this is this is going to be the governance system that comes out of phase one, and this Dandelion DAO will allow token holders to vote on and approve on all the parameters that are going to launch the conviction voting and the bonding curve. And once the conviction voting and the bonding curve are launched, the Dandelion DAO is not expected to be active. It's not expected to be an active mechanism. It's there in case something needs to be drastically changed that conviction voting can't cover. But its main purpose is to just have a sort of system one voting mechanism that allows the community to, in a decentralized way, come to consensus on the parameters for conviction voting and the bonding curve. So if I have, Mhm.
It's like amending the Constitution versus like iterating within the scope of the Constitution.
That's such a good metaphor that I've never heard before. I think that's exactly what it is. Yeah. Okay, so let's click in here in the hatch. So what we did is this is the template. This is it started it. This is a fork from Aragon Garden launch template. And I haven't been so active on like the contract development and sort of the historical side of this. I know a lot of this originated from Aragon. OneHive has been sort of the active development team that's working with the TEC. It's really cool to see this stuff emerge. It's in a very decentralized fashion, so much so that it's really hard to track who's working on what and what's even being developed. It's just seems to be everything will just be finished one day and someone's presenting it. So it's been a really cool experience with the TEC. But this is the Gardens template, so it's Aragon DAO template to experiment with public community coordination. And the key here that we're going to look at, the purpose of the modeling that I've been working on, is if we go into the scripts directory, there's this new DAO.js. And this is sort of like the configuration file for launching a DAO. And so we have a DAO ID, token owner, network, zero address. So a few constants that we use for convenience. So we can see here this has remnants from OneHive. So it's talking about the collateral token name is honey, collateral balance, org token name, org token symbol. Okay, so now we're getting into the juicy stuff, which is the Dandelion voting parameters. So we have support required, minimum acceptance quorum, vote duration blocks, vote buffer blocks, vote execution delay blocks, tollgate fee, pre-sale goal, pre-sale period, open date. So the first thing is when we talk about not being a technocracy, is like all of these parameters are extremely important, but how do we expect people to first of all find this repository, find this file, open it up, not be completely scared away because it's like crazy JavaScript, and then actually read and comprehend these parameters, understand what they are to the extent that they can have an engaging conversation with the community and bring their ideas to the table for open discourse. So this is sort of like the requirements gathering phase. So what we did, this is this most of what I'm talking about, this initiative is led by Griff Green. That this is really, he's had this vision and he's been really good at sort of sharing it to the community to the point where it's become a decentralized movement. But yeah, this is definitely coming from all the work that the Common Stack has done. Jeff, of course, on this call, and a whole whack of other people. So moving into the forum post, this is the technological specification. So for every single individual parameter, we made a forum post. So let's see I think if I open up this one, hatch parameters, general discussion. Yeah, so here, this is pretty cool how this is organized. So this is just laying out this idea that we need to flesh out all these parameters. And how we did this, actually, we launched a DAO, a test DAO, back in maybe November or December, and we just used the default parameters and we launched the DAO, and it had there was a maximum one test die that you could invest. So it wasn't real, there wasn't a lot of money on the line here, but we just wanted to launch this with the default parameters, see if it works, get an idea of what it feels like, and then we have something that we can bring back to the community. So we laid out everything here, how that test hatch went, and then we said, okay, based on this information, it's time to flesh out these parameters and explore them. So we made a deep dive forum post on every single parameter. So there's the hatch goal, the hatch time limit, the hatch return. So what happens if the hatch is aborted? Do all funds return to co-vestors, or is there some portion that we want to keep? So C-stack ratio. So what we're doing here, because this is an initiative, this is an instance of the Common Stack deploy, for the phase 1 of the hatch, only C-stack token holders have the ability to actually invest in the hatch itself. Because what the hatch phase 1 is trying to accomplish is to create a very tightly integrated, aligned community who is all on the same page. We're not trying to attract external investors here. We're trying to pool funds to sort of bootstrap this initial phase 1, and then in phase 2 the bonding curve opens up the external investment for anyone in the world to invest into this community and the token. So we have impact hours. What kind of formula are we going to use to pay out people? What's the impact hour rate going to be based on how much we raise? So for every parameter, we've made a specific forum post that fleshes it out. And this forum is like always evolving. It's interesting to see the structure right now. It's different than last time I looked at it. So this will be a very nice artifact post-launch to completely reference for any sort of future common stack deploy. Okay, so once these parameters have been fleshed out and the whole community has been given a chance to have some dialogue and discourse and sharing on sort of how they see this, and maybe they have some opinions they want to share, then we move into the mathematical specification. So actually, let me go back. Was that impact hours? Yeah, impact hours rewards. This is really cool. So this discussion on impact hours led to an awesome formula from Sem. Sem's very active in OneHive and the TEC, and he came up with this impact hour formula, which essentially has two parameters. Let's see. So it's based on the total number of impact hours from the community. M is the slope, so it's how slow our impact hour payout grows. I call it like how strict we are on ourselves as a community. And then R, this is a neat one. This is the cap on impact hours. So this is like, let's say theoretically we raise 100 million XDAI. Well, based on the formula, that might mean we're paying out all our community members 500 XDAI per hour. And we just want to have this ability to say, well, that's kind of unreasonable. We don't need to be paid out 500 XDAI per hour. Let's just put a hard cap on it. So you can think of this as being roughly 100. So, if we hit all of our dreams came true with the bonding, with the hatch raise, then we would have this maximum cap on the impact hour rate. And so Sem came up with this very cool formula where on the x-axis here we have the increase in the amount that we raise as a community, and on the y-axis is the impact hour rate that people get paid out. And so he plugged in the default values here. Total impact hours as 6,000, which I believe that's pretty closely accurate to our trajectory. M is 1,000, and max payout is 210. So we can see how that payout function grows. So this is how some of the mathematical specifications started to arise. Now what you'll see here is these are not necessarily complex adaptive dynamic systems. This is a straightforward equation. So the modeling that we're going to get to is quite different. It's not a typical cadCAD environment. In fact, I'm not even using the cadCAD library yet. I'm building something that's very complementary and sort of could think of it as like a not a prerequisite, but like a prior step to cadCAD modeling. Once you see what we've got, you'll see, oh yeah, you could then throw this into a cadCAD simulator and see sort of the interaction between the components. Because what we're doing so far is we're going to be modeling all these individual parameters and seeing their impact on the potential raise. And I think the next step for this would be to consider the interactions between all these parameters and all these different components of the raise.
So I would comment that with what you're describing here is very much what the Block.Science team does with the mathematical specifications, where you're building lots of little input-output logical pipes and defining them locally and as legibly as possible. There are lots of little algorithmic policies, and that when you put them together into a cadCAD model, you're asking something about what would happen when you put these things together under different circumstances. So you can't really do the cadCAD coding thing if you haven't first done the logical modeling and then understanding all of these little input output pipes as bits of if this then that. Because if you just put put a bunch of random stuff in a cadCAD model, then you're just getting a what if that you don't understand. So if you haven't put together all the parts and understood them individually, you don't get the same utility out of putting them into a complex, adaptive, dynamical model and seeing what might transpire.
It's so awesome to hear you say that, because that's been my intuition, and that this is such a nice, like, all of this work needs to come first. Like, to try to jam all this into a cadCAD simulator without fleshing out the individual components it would just be confusing. It would be so hard to figure out what the actual results mean, and where they're coming from. So it's nice to.
Sure, Barlin wants to hug you right now.
What's that?
I'm pretty sure Barlin wants to hug you right now.
Oh. Awesome. Okay, so what we did here, this was like months of work, and kudos to Jake in the TEC. He was just on people. Check the forums, check the forums, check the forums. And because it really is that. We're trying to really drive community participation in this. And if you guys see this, I can link, we'll get this linked because Sem made a really cool little simulator here. I think I'll just link. Yeah, this is cool. Desmos.com. You can like plug in simple math formulas and just whip them up. I think I'll link this. Discord. Oh, too many things. Okay, I'm gonna. Oh, there it is. And cadCAD community. Sweet. Okay, so yeah, moving on. So we have all these to play with, and so what this inspired me to do is I felt this need for more interactive development sessions in the TEC, because there were so many working groups doing so many things, but it was almost too extreme. Like, we don't want to be a technocracy, so there was always these like soft governance and communications teams and everything, but for me it was like a bit extreme. There was like almost an aversion to the open technological development. So I wanted to make a middle ground. So I initialized these lab sessions every Friday, and those are going every Friday in the TEC. And so that's here. There's a workspace, and I'll just share this as well in the community here. And so how we've utilized these labs is we did a series at the beginning on just sort of onboarding people into the token engineering mindset and environment, in general, just kind of data science stuff like going over GitHub, Python, Jupyter, simple stuff like that. So we did like a 3-part series, and then we just moved right into utilizing these lab sessions to doing some modeling on these hatch parameters. And so I think I'll just jump into it. I should have the lab repository here. And I think I'm going to go with, in lab 8, we have like kind of our final working version, but I think I'm going to open up lab 7 because it's a bit more raw and you can actually see what's going on. So TEC, and I'll just okay, TEC lab 7, and this, I should have cleaned this up before leaving it, but okay. So we're gonna model all the components one by one, and we end up having essentially 4 components, or you could say 3. We have 3. The impact hours component to this hatch, which is also here. And we have, this is the actual hatch. So we're going to go over CStack token holders and how much they can actually invest, and how that could result in various funding pools and hatch tributes. And then this is my favorite part. This is the Dandelion Voting configuration. It's also the most straightforward. But I'll go through this one by one. So this is using, and I think my goal here is to really bring light to a whole ecosystem of tools that is the PyVis ecosystem. because I think this is extremely complementary to a lot of the work that people on this call are going to be doing when they're looking at cadCAD modeling. So dashboard. Okay, this is so Voila. I know Danilo just shared something about Voila, which is a way to sort of launch apps straight from Jupyter Notebooks. And what you're going to see here with making these sort of interactive widgets is, oh, let's hope this runs. Let's run this. Is this library Python panel. And panel is a very high level dashboarding library for sort of stringing together visualizations and adding interactivity to them. And it pairs really nicely with, there's sort of a full stack of tools. It starts with a primitive, like a visualization primitive called Bokeh, which I'm sure most of you have heard of. So that's a visualization library. On top of Bokeh, there is a library called HoloViews, and it takes a totally different paradigm towards data visualization. And I love how they put it here. It says, stop plotting your data, annotate your data, and let it visualize itself. So what this means is this library knows how to visualize data based on the axes labels, index and column labels of a data set. So it works really nicely with pandas, with higher dimensional data like Xarray, NetworkX, things like that. It's a completely different paradigm from something like Matplotlib or Plotly, where you're always passing in your data structure and then telling the plotting library what you want to see. In this case, HoloViews is actually a data structure. It's a lot like a pandas data frame. It's a data container. A HoloViews object is a data container. And so you can instantiate it from a pandas data frame. And then once you have this HoloViews object, it knows how to plot itself. You don't have to really tell it anything. You just kind of invoke whatever visualization you want to see. And so it makes visualizations really easy. And it has also in it built in a two-way communication system. It uses WebSockets, so you can link HoloViews plots very easily, and that's what allows us to get, it's the same mechanism. It's actually all from an underlying mechanism called Python param. And I think this is the greatest kept secret in the world of Python development. This little simple library called param, I think it's just one Python module with no dependencies. And what it does is it allows you to parameterize a Python class, which means that when you give that class attributes, you set those attributes to param objects, like types, essentially like numbers or booleans. And say you set a to a number, then you give it a default, you give it bounds, and you can give it a docstring. And once you have these parameterized classes, they know how to turn themselves into widgets. It's the same concept of HoloViews. Stop plotting your data, annotate it, and let it visualize itself. Because if you have a parameterized Python class, then it just you get these widgets for free. You just print, essentially you display this object in Jupyter Notebook, and it'll know how to render itself with these widgets. And that's what we've done here. So we're making this impact hours data as a parameterized Python class, and it's just got so it's got predicted hours and total impact hours. Let's see if this is working. I think, honestly, you guys, I updated my Jupyter Notebook, Jupyter Lab, just the other day, and this stuff just stopped working. This just happened yesterday, so it might be connected. I was just in the cadCAD sort of development call, and there was this issue going on with Jupyter Labs, and I wonder if there's been an update, because this is really sad for the demo. But okay, so what should happen when I move this slider is what I've done here is these are the impact hours, cumulative impact hours of the TEC. And so up until this point, January 15th, this is real data. This is real impact hour accumulation. And what you see here in the blue line extended is the projected impact hours. So if the trajectory continues as it had, then we will have this blue line of impact hours. In green is sort of the optimistic case. This is like curving. Instead of having an exponential growth of impact hours, it would be better to have a linear growth. So if we had this linear growth, that we call that the optimistic case. And then I'm saying the predicted case would be somewhere in between historic and optimistic. And so that's what we get with this orange line. And then what I do is I just take like a linear space, just like I just scale this curve between green and blue, so that as you move this widget, like I'm thinking on the fly if I could solve this, how I could solve this, but I don't think I want to go down that rabbit hole of trying to troubleshoot this right now, because that could end badly. But if anyone else wants to like in parallel run this, I'll just link this. If anyone wants to like on the fly try to debug this. I think it was the Jupyter Lab update that just came out. So this should be an interactive widget. Anyways, we can say, and the goal of this whole project is to have this template, this parameters template, and remember this all maps back to everything in this hatch configuration file. So we can give this to a community member who's not a coder and allow them to have a voice in this case, what they expect. What are their expectations of the community? Do they expect we're going to run way off with our impact hours, or do they think we're going to curve this or flatten the curve, so to say, with impact hours to start? And someone have a comment? I heard a little something. I'll keep going. So the next thing we have is this impact hours formula, and this is what we saw earlier being modeled through the forum. And what this is this is the curve that we saw, and we can slide these widgets and say, okay, what's our minimum raise? And this is a parameter in the hatch that says if we don't meet this raise, then the whole thing aborts. What's the expected raise per impact hour? This is that variable m in the impact hour equation. Maximum impact hour rate, yep, this was r in that equation. And as you move these widgets, this curve should really be moving. Target raise, this is going to move these crosshairs. And also this whole thing's being refactored. It's going to be much simpler. We're not going to have two crosshairs, just one. But as you shift your target raise that you would like to see the community achieve, it's going to shift these crosshairs, and you're going to see how the impact hour rate changes from that. And then based on what you put here, mainly this expected raise per impact hour and target raise and minimum raise, we can actually see what the minimum raise to have a successful hatch is, what the expected raise is, and what the target raise is. And these will actually fluctuate based on the formulas in here, based on impact hours. We'll see what percentage of the raise is going towards the cultural tribute, that's the impact hour payout, and what percentage is going towards the funding pool. So then we have here in the hatch, we have CStack token holders. So these are ranked from basically by their wallet amount. So index 0 here is the highest CStack token holder address. In this case, that's Griff Green. And so this is a distribution of CStack token holders. And the different colors on this curve are, in blue, we have the maximum possible wrapped XDAI they could stake into the hatch, and that's based off this parameter called the hatch oracle ratio. And this means for every one CStack token you hold, how many wrapped XDAI are you allowed to stake into the hatch? It's a cap on co-investment. And so for the test hatch, we have this default to essentially 1 penny per CStack token. But as we shift this, these should be shifting up and down and showing different amounts. And what this means on the y-axis here is XDAI staked. So I think this is given the default parameter, which is 0.01. Griff Green would be able to invest a max capacity of 400 wrapped XDAI into the hatch. And then we get this sort of distribution here. And what we see in this table here, it's probably the font is too small. Oh, that might help a bit. So given the parameters that are set up here, the max raise, min raise, hatch period, hatch exchange rate, and hatch tribute, we get the maximum possible raise. So this is based off this hatch oracle ratio. So if we increased this, we would see this row increase. So it's the maximum possible raise that can happen based off the oracle ratio. And in this case, with default parameters, it's 3,560 total. And here we have the geometric mean per hatcher. So this means your average hatcher in sort of the middle of this distribution is expected to invest roughly 14 xDai into the hatch, and then it's a geometric mean, so we get orders of magnitude. So the top C-stack holders would be expected to invest, say, around 140 xDai, and the long tail of this C-stack distribution would be expected to invest about 1.4 xDai each. And then we get calculations on how much xDai is going to go towards the hatch tribute and how much is going towards the funding pool. And to differentiate these, what these mean is the hatch tribute is just a non-redeemable investment. And it's a percentage here. It defaults to 0.05. It's kind of like an ante when you're playing poker. It's like even if you fold, you can't get it back. So if you don't like the way the DAO is moving into phase 2, and if maybe you don't like if you see a proposal is going through with the Dandelion Voting, then you can always take your money back and exit, but 5% will be left behind as a hatch tribute. And then based on these parameters, we get the total TEC tokens being minted, and this can be scaled based on this hatch exchange rate parameter, and this doesn't change anything anywhere. It just changes the number of tokens that are being minted. So this one, I'm excited to see how the community will play with this, because it won't change. It'll literally change nothing about any of the charts or the distributions or anything. It'll only change the number of tokens in circulation, and then of course if they were to be traded on a market, their price. So it'd be interesting to gauge how many tokens the community thinks should be minted. And then finally, based on all of these parameters, we get what the funding pool would be based off our minimum raise, our maximum raise, and our target raise, and the maximum possible raise based off the hatch oracle ratio. And these are all dynamic charts. So this is honestly, it's so unfortunate that this is not working. I wish I had looked into this just last night or this morning, because I bet I could figure out something to get it going. But I could probably just maybe install a previous version of Jupyter Lab. That might work. Let me try a couple things.
Do you want to try to do some async Q&A while you try to get this up and running? 'Cause
Yes.
I think that would be.
Yeah, thank you. That's a good idea.
I'm gonna make. Go ahead.
You said you were going to test the Python version for me in the previous call. Maybe the Python version is what bumped it?
Oh, wait, did I
You were testing 3.9.1 for me.
Yeah, okay. So because my virtual environments have specific Python versions, so this should be Python 3.8. I also
Shawn, there's that one weird requirement that panel has.
let me check that one. I also have this other virtual
Okay.
environment, which is TC Lab. Oh, virtual fish. Activate TC Lab. And I'll
Потом удивляешься, почему 9 метров.
I think it's on the README.
Yeah, the requirements file in that repo also has a lot of duplicates which are contradicting with each other. It's almost like someone appended to the requirements file instead of overwriting.
Oh, geez. Does not support current version of Jupyter Lab.
The curse of live demos.
Yeah.
So what I was gonna suggest for because we have a lot of people on, if you wanted to try to take a minute and sort the dependencies by sort of just switching back to old versions, we could. I was gonna invite Barlin if he wanted to talk about how this kind of work connects to the cadCAD modeling, because within our team we do quite a lot of math specking, both analytic work and sort of checking little individual mechanisms before we wire them up into cadCAD, these dynamical systems models. And I thought he might comments about how the work relates to each other so that it's relevant to people who came for the cadCAD call.
Sure. Yeah, I'll just mention that, like one of the key steps that we do in the design before we get, so kind of what Sean was referring to, that if you just, model a complex system and you get a whole bunch of results, but you don't know whether those results are telling you actual, results about complex adaptive systems, or whether whether you actually have not wired a component correctly, or even coded it correctly. So a common step for us would be to do something similar, that we often start with a Desmos and say, oh, like this looks like a good algorithm, and then we will often make a cadCAD model where we are just testing that component, and verifying that component does exactly what we expect it to do in that kind of controlled verification environment, where you're expecting, I have a known input, I have an expected output, and doing a proper comparison between those two things. So so that is absolutely part of essentially the scientific method that we employ.
Do you guys put together? Do you guys implement sort of like production lines where, or like, is one person working across? Like, would one person be focused on one project, or would one person be focused on one sort of piece of the production line across multiple projects? Does that make sense? Because there's these there's the mathematical specification, there's this initial phase that we're seeing here, which is the I don't know what the terminology would be for this phase, like sort of sanity checking or initial modeling, non-complex modeling, maybe.
Yeah, this is the verification model.
Oh, verification model. Mm-hmm.
Yeah.
So there's like the pipeline that we have kind of go to answer your first question about like whether we generally have one or two people like working on a project through its whole life cycle, but then we also have people jumping in and out based on their expertise in different parts of the flow. So think of it more like if you think of it as a matrix, you have the progression through the different kinds of work, the pipe as you described it, and then you have the people, and so then those people, the projects, and I guess it's a tensor. People, projects, and the expertise, you start having to make sure that a project goes through the whole sequence, and at least one or two people will be kind of owning that project all the way through, but they'll work with their teammates to make sure that the necessary skills in a part are met. So I'm stronger, for example, at writing the algorithm derivations, the analysis to derive a mechanism. So then, although I might live through a whole project, at different stages in that project, I would lean on someone like Danilo, who's like really talented on the implementation side, to make sure that we get through maybe some of the late stage stuff, which is hardcore computational like searches, like massive experiments and evaluations, or just the implementation of the model in the first place. And so I'm rambling now. God damn it. Basically, nuts and bolts of it are at least one person follows a project all the way through, but the team flexes around where their focus is based on their expertise to make sure that we run the whole gamut.
You're not rambling, you're stalling. Thank you. Maybe this will go. Let's see. Okay. There we go. Okay, this is the going now. Yes. So I just reverted back to Jupyter 2.2. So something's up with Jupyter Lab. So this is the sort of a vanilla example of how we can start to get these interactive plots. And this functionality really, it does, okay, so this is a simplified interface. I think I'm going to jump back to what I had open before, so you can actually see the code behind this. Okay, so this is, like I said, this widget is just a simple, this is predicted hours. So this is a scaling factor that I've made into a param widget. Param is just a param number. And then I have this function. So how this works when you're making parameterized classes, you just make a function that's going to output a visualization. And if that visualization depends on any sort of parameter, then because this inherits from the parameterized class, it will re-render anytime that parameter is changed. So we get this widget for free, and then because this output visualization is using this, the value of this, so it's predicted hours. So where are we using that in here? Self.predicted hours. Then it knows to re-render based on this parameter changing. So this is like, I think this is going to be a key piece of the ecosystem, plugging into cadCAD, especially when we get to the dashboarding phase of things, which is something we've been talking about a lot in the OneHive community. Okay, so now we should see, this should give us, so this minimum, minimum raise doesn't, you just see it sliding at the bottom there. Expected raise, this is going to shift the curve, and we can see how these funding pools change. So this is increasing the expected raise. Maximum impact hour rate is sort of, so if we set this to 0, then 100% of the funds are going to go towards the funding pool and there'll be no cultural tribute. Whereas if we fill this to capacity, then we notice that all of the funds end up going to the cultural tribute based on, we can increase this expected raise, and so we can start to play with the interactions between these parameters. Minimum raise. Okay, so now this should make more sense. So as we increase this hatch-oracle ratio, you can see just basically the y-axis here is scaling, which means each C-stack token holder, it's the same distribution, but each holder is allowed to invest a higher amount. And I've made these are simply scaling factors, and so what else can we play around with here? So that, yeah, and the key here is what I'm trying to build is something that inspires people to really play around, because there's so many dynamics here that are, like, just for me to comprehend, are quite confusing. But I know if this was in the hands of all the community members, there would be various different people would pick up on different dynamics. And so I notice we're almost out of time. The final piece of this is really cool, is Dandelion Voting. So support required. This, yeah, there's been so much confusion in the history of DAOs on what these two parameters actually do, and it took a long time for me to actually get it, and the process of making this visualization helped a lot. So what we have, support required, is the percentage of tokens that vote that need to vote yes. So we can set this up to 90%. So what we have on the x-axis here is total token votes, and on the y-axis it's yes token votes. And so this boundary between green and red becomes the boundary between a proposal passing or failing. And when I talk about this stuff being really complementary to cadCAD modeling, it would be so awesome to, like, have this as kind of like a backdrop, and then we could simulate the voting process and see it rendered over time. You could get this kind of curve that would, you could imagine a highly controversial vote would, like, oscillate between passing and not passing, depending on the parameters of the how the vote are set up. I don't think it would oscillate back and forth, because I think when a vote enters the green area, it passes. I don't think it has to persist there for some time. But again, clarification on the parameters is so nice, and remember that each of these parameters has a corresponding now a corresponding forum post that completely fleshes it out and opens up space for dialogue. So this is how we're trying to solve this technocracy issue in the DAO space and in the crypto space in general. So what minimum accepted quorum is it's the percentage of all tokens that have to vote yes in order for a vote to pass. So this visualization nicely allows people to develop some intuition around what these parameters, how these parameters are going to shift this Dandelion voting instance, because the green space is where a vote passes. And this is my favorite parameter. This is the rage quit hours. This doesn't change the chart, but this is like if the vote passes, so essentially if the DAO is moving into phase 2, this is the number of hours people have remaining to abort and take their refund minus the hatch tribute. So yeah, thanks everyone for tuning in. I feel like I feel like I had a nice conclusion in my head, but I've kind of lost it. But I hope this inspires you to mainly just check out this panel library. This is going to be huge in the ecosystem, all open source, made by good teams. And this comes under, really it all rolls up to this guy, Travis Oliphant. If you don't know Travis Oliphant. So he's the creator of NumPy, SciPy, Anaconda, everything, all these things, and he funds, his organization and his sort of network is largely behind this ecosystem of tools in the PyViz ecosystem. So this is a pretty cool rabbit hole to go down. Just an aside to leave you with. And is there any questions or anything else?
I wanted to make a last point too that was just sort of encompassing this in with our broader cadCAD work, is that there's a really high focus on making informed participation. And I think that, when it comes to launching a system, this is the informed participation. And that, like, in a way, taking these systems post-launch, and we talked a lot about digital twins, for example, in our cadCAD core call earlier, the working group call. And, it's important to recognize that you get these things designed and agreed upon and launched, and then they're running, and you have models, and those models help you understand what's going on, and all of this rolls back to informed participation. And I think we're entering an era where, like, informed participation includes making algorithms themselves legible. And that means data science, and that means data visualization, and that means math specs describing components of logic that are in those platforms, etc. And so I think it's actually a good place to be thinking, because the more complex dynamic models are not actually useful if you can't understand the parts that make them up, because then you don't know what you want to change or what it would mean to change it. And so it all does tie together really nicely. And I think as a community, whether it's data viz or modeling or running simulations, this is the collection of technologies that we need to become comfortable with and to contribute to advancing.
Absolutely. And one of the final points, I don't know if Shawn mentioned it yet, but all of these simulations are going to be wrapped into a kind of a community front end. So anyone who is participating in the TEC will be able to get their hands on these parameters, not just reading the forum and contributing in the discussion, but actually setting the parameters, hitting this is my proposed parameterization of the TEC hatch, and of the various components involved. And then the community can engage in a discussion with multiple proposals of different parameterizations and determine, which one is the one that we want to move forward with. So ultimately, this is trying to bring all of the technocratic decisions. In most DAOs, these decisions are just made, and that's how the DAO is set up. And what Shawn is doing here, and the TEC as well, is opening those decisions up to an engaged community. And obviously making it much easier to understand and comprehend with all of these visualizations, and understanding the intricate interplay between all of these parameters, because they're not just a walk in the park. So yeah, really, really interesting stuff. I'm stoked to see the introduction of the panels and the interactive widgets. I'm glad you got that sorted out, because I think that's a really cool feature that brings a lot of this modeling a step closer to the end user who's looking for the information, but maybe doesn't have the the data science and complex systems background to be working in cadCAD models. So this is a great way to present that to a non-technical audience in a way that they can understand better. That's great. Thanks so much, Shawn.
Yeah, thanks everyone.
And I noticed, yeah, definitely. So we're at the top of the hour, so I won't keep anybody here. If there are any final questions for Shawn or Q&A, we can definitely field a couple of questions, but if you have to run, absolutely understood.
Shawn.
Thanks, guys. Cheers.
Thank you.
Bye, guys. Thank you.
Thanks so much, everybody. We'll see you in the next call.
Thanks, Shawn.
And for anyone who is interested, we do have working groups that are taking place on a weekly basis. Feel free to drop into some of the other Discord channels if you're interested in outreach or infrastructure admin. I can send you some more details in the channel there. Thanks very much. Catch you later.
Thanks a lot, Jeff. Take care.
Yeah, thank you, Shawn.
Yep.
We'll chat soon.
Yep. Bye, everyone.